Well, welcome everyone. Thanks for joining. It's going to be the tech talk about Azure Level Function. My name is Angel de Hoyos. I'm going to be hosting this talk, and well, we are about to begin. So, well, the topics that we are gonna touch on today. First, we're gonna have a brief overview of what Azure Level Functions are and how they work in a broad way. We want to take a look at some of the most common application patterns that you can use when implementing the Azure Durable Functions. We're going to have a quick live demo. We're not going to go in depth of all the patterns or all the functionality that you can integrate with Azure Durable Function. It's going to be a quick demo so you get a feel of how an application like this is going to be implemented and how it's going to be managed. Then we're going to go over some quick things you might want to keep in mind if you're planning to implement this in a project or start an integration of their own. And finally, we want to recap what we are going to see in this presentation. So, what are Azure Global Functions? Well, basically, they are an extension for the already existing Azure Functions. Probably many of you already know and have used Azure Function in the past. This is just an extension that adds functionality to the already existing framework. It lets you write stateful workflows in a serverless compute environment. And basically, with the already existing programming model of the Azure functions, you can write your logic for your application, and it's gonna be executing seamlessly in a serverless environment. So you don't have to worry about having a running server and making updates and security patches. All is going to be taken care of by the Azure services, and it's going to be running on the first available VM. It's going to take care of all the requests and functions are going to be running. Behind the scenes, manage the states, checkpoints, restarts all seamlessly. You don't have to worry about all that. It supports several languages, mainly the Microsoft technologies, .NET, C#, even F#, which are we're going to be focusing on C# on this presentation. But if you are so inclined, you can also implement the Azure Global Functions from JavaScript, TypeScript, Python, PowerShell, and recently Java, which is not totally supported yet, but most of the functionality is already available in preview to use Java. It's an open source project. It's based on the Adaptable Task Framework, which is, I believe, also an open source project, with the implementation to the Azure functions is well, mainly developed by Microsoft, but is open for contributions for the community. If you are interested, you can look up the Azure Durable Functions repository, and they have a guide to contribute. You can take a look at that if you're interested. And well, the orchestration works basically like this. First, you have an Azure function, an ordinary Azure function. This Azure function can have any trigger of the triggers you probably know already for the Azure functions. Can be an HTTP trigger. You expose an endpoint. So when a request made to that endpoint is going to be triggered Azure function, might as well be a timer, a queue, maybe an event in the blob storage. There are some other triggers you can do, but this function, the only purpose that it have is to start the orchestration. It's gonna be code. Maybe it can make some validation if the orchestration is gonna be run or not. And if it's all well and good, it's gonna call the orchestration, which is basically another Azure function. That if you see the first function is gonna be terminated, it's not running anymore, which is important. In a minute, we're gonna talk about how uh, how is built the Azure function, which is basically by time use, by the millisecond, I think. So if you may have thousands of functions running, but if they took milliseconds, it's not gonna be much of a expense there. So the task that starts orchestration go to sleep or is finished. The orchestrator is basically another Azure function, but this one has a special context. The context is stored in Azure storage, which is important. You need Azure storage to run and implement and draw project with durable functions. And in the context, you have all the information of the task that is going to be running, some variables that's going to be persisted through all the life cycle of the orchestration, and the orchestrator is going to start a look of all the activities that is going to need to perform. So it's going to start the first activity. You notice the orchestrator is gone. So basically, it's not finished yet, but it's going to sleep. It's not going to consume runtime in your Azure Functional Service. The activity is gonna take whatever it's gonna take. This is the beauty of the durable functions, that doesn't need to be on real time. Maybe this activity is gonna take minutes, hours, maybe days, weeks, doesn't matter. It's gonna take whatever it takes. Once it's done, before it's completed, it's gonna wake up the orchestrator, and that activity is finished. The orchestrator is gonna take a look at all the activities that it's gonna take. Is gonna notice that the activity one is already done. In fact, the orchestrator context already have the return value of the function one, of the activity one. So it knows already that the activity one has no need to be run again. So even though the orchestrator is rerun, it starts from the beginning, it's gonna skip the activity one and go right ahead to activity two. Just like the last time the orchestrator got to sleep, the activity two does its thing. And this example, let's say this orchestration only has two activities. The activity two terminates its job, and before finish, wake up the orchestrator. The orchestrator receives the return value, and there you can maybe add some logic to do with the return value of both activities. You can maybe trigger another orchestration to start a new workflow. You can store the return values in persistent entities. You can do, well, many things. And once it's done, it's going to update the status in the storage, in the context. And basically, it's going to clean up and it's done. So basically, in a grand scale, that's basically how it works. And now we're gonna go ahead and look at some application patterns. I don't know if at this point anyone have any questions or something. Okay, well, we want to go ahead. Well, the first common application pattern is the function chaining. Uh, you might be thinking, well, this is has nothing special. Or I can do already that in many other frameworks and languages. I can have a string of functions that's gonna be using the result of one function in the next one, and so on and so forth. But the beauty of thing is that you can have this all run seamlessly. It doesn't matter if maybe the function one is gonna be called in real time, but the function two is gonna take maybe hours. It doesn't matter. The orchestrator takes care of all that. And once the function two is finished, it's gonna take the value, go forward and run the function tree, and so on and so forth. So it's very, very seamless. And the second application pattern is the fan in, fan out, which traditionally, if you wanted to implement something like this in a regular uh, Azure function application, well, you would need to keep track of all the functions. Maybe you have a function that triggers more functions, and they are running in parallel. So this is very important. They're running parallel, and it's very hard to keep track of which functions are done. If some functions need to wait for some other function to finish before it starts. The orchestrator is already prepared to take on parallel tasks, and this makes it very effortlessly. And one thing to keep in mind is that all these application patterns that we're going to see, they're basically Lego pieces, if you want to think of them like that. You can maybe have a function one that has a fan out, make some work, then when all the applications, all the functions are completed, then fan in and run another function, which in turn can be make a function chaining, and so on and so forth. And it's all very easy to use. The third application pattern is the async HTTP APIs. So maybe your application needs to use an external API. So you can have the logic to be polling an external API to see if if it has work done. So you can continue. You can validate the data that is coming from an external API, and the integration is also very easy. And the next application pattern is monitoring. You can make an orchestration function that maybe has a timer that every, I don't know, a few minutes or a few hours, whatever you want to configure it, is gonna pull an external service. Maybe you can make an application that tracks a cryptocurrency value or something. Maybe you can feed that data to a learning algorithm, or maybe you just want some alerts or notifications. Conversely, you can also pretty much invert the last pattern. Instead of making an application that pulls an API, you can make an Azure function that is going to be pulling. Well, the another pattern is human interaction. This is also very common, and the durable function addresses this scenario. Basically, you can expose an HTTP trigger. So let's say you have maybe an expense report that is going to be sent to an employee in the finance department, and you can wait for that person to either approve or deny the expense report, or maybe the user can escalate. Maybe the expense report exceeds some amount and need to be escalated to the head of the department, or maybe you can set a 72 hours timeout. So if the user doesn't have a response either approving or escalating the expense report, automatically after the 72 hours can escalate it, and all the workflow. It's very easy to implement it in code. And lastly, the aggregator. Besides the function and the activities, the durable function also have which are called stateful entities, which basically are entities that are persisted in the storage, commonly the blob storage. Formerly, Cosmos DB was an option, but I think it's deprecated. I'm really sure, but at least at some point I did use Cosmos DB to store stateful entities. So the beauty of this pattern is that maybe you have an entity that is going to be feed from many sources, maybe different users, different companies, different APIs. All of these are going to be adding or editing or deleting information from an entity. And if you were to make something like that in the past, well, you would have to make some consideration for the concurrency and the preservation of the integrity of the data, and so on and so forth. But the durable functions, the orchestrator have a built-in an application pattern, so you can make all this seamlessly, and it automatically takes care of the concurrency. It doesn't matter if some of the modification takes months, or some of them can be at the same time for different users. It all makes it very, very easy. So we're gonna go ahead and make a quick live demo. I don't know, you can see Visual Studio right now?
Yes, well, not anymore.
Well, there is.
Yes.
Well, I have already a quick demo here, but first I wanna create a new one really quick, so you can see how easy it is to start a new project. But in Visual Studio 2022, it's already integrated for the .NET SDK, so it makes it a lot easier. Some time ago, you would need to start an extension, but now it's already integrated with SDK. Well, you start a new project, you search for functions. is basically is not different from an Azure function application. So you're gonna pick that. You're gonna name your project, and you need to he's gonna add first a function. You can use these presets. There's already one for durable function orchestration. And like I said before, when previously when you make a simple Azure functions, you can get away with not using storage. If your functions doesn't explicitly use storage for some task, you can not use any storage, but the durable function needs storage because it keeps a history, a ledger of the activities that are in queue or that had already been run, and so on and so forth. So you need an Azure storage account. Well, to deploy maybe, but for local development, you can use the Azure Storage Emulator, which uh, which is free. Once it's created, you're gonna have a quick boilerplate code here to just a simple durable function for chaining functions. And not now. You can see here it's already configured to the Azure Storage Simulator. If you were to implement it in the cloud, you would need to set up an Azure Storage account. And well, now with that out of the way, I'm gonna go take a look at this demo. So basically, this function is the same of the boilerplate. It's gonna be chaining. Well, more importantly, first we have this function, which is triggered by an HTTP request. This is the function that is going to be starting the orchestration. And once you call this function, is going to start the orchestration. It's going to have a durable orchestration context. And here you add a call activity syncs to the context, and you await them. At the same time, you add the result to the output. It says here await, but the orchestration, when they see an await, basically it says like, okay, I'm gonna wait for that. I'm going to sleep. So the orchestration is finished. It updates the history of the orchestration that this function is running, and go to sleep. When that function is completed, the orchestration wakes up and continue from there. And we can make a quick demonstration. I'm gonna stop it. Run it again. I'm gonna run it here. Well, once you run it, it's gonna give you these endpoints that you have implemented in your application. If we going ahead and run this one, You can use, even I can call it directly here from the terminal, or maybe use a browser. But let's do it here in Postman to see the result, which is important too. Once you run it, you can see it's trigger. It does it work, and it makes a log of it. The login that used by default is the Microsoft log, which is already configured to use Azure Insights. So if you're familiar with Azure Insights, you won't need to make any other adjustment. It already is configured to do that. And when you run this endpoint, you have this response. And you can see there are several endpoints that you can trigger. First, you have the ID of the orchestration, which you can then, if you need to, check on the storage to see directly the status or some other information. And then you have another endpoint, which is the status query. Now, if I run this, you can see that you have a runtime status is completed already, which is to be expected. It's a simple function. And I have the output here, all the three functions that were going to be run. You can see, say hello to Tokyo, Seattle, London. And we have all the output here. You can imagine if you integrate an external API to consume this result, you can use the query URI. So the external API can pull the status of this and can it can pull the status. So if it hasn't completed yet, it waits or try again, etc. etc. Now we're gonna see another quick example, which this application pattern is the fan in, fan out. You can see it's very similar to the previous one, but if you notice, you have a list of tasks, and the tasks that we are going to be executing are not awaited. They instead are going to be added to the list of tasks, and then we want to await all the list of tasks, and we have this method when all, so which means that it's gonna take all the tasks that are in the list, and then it's gonna wait until all of them are completed, and until then it's gonna continue with the orchestration. Alternatively, you can maybe use when any. So you have all the tasks run in parallel, and you don't care which one, but the first one that is done, you continue with the orchestration. So for this example, we wanna keep when all. The function that basically says hello. I added a delay, which is a random value between 5 and 10 seconds, to illustrate some of the behavior in parallel. So as we had hit before, is the other endpoint for the fan out demo that we have right here. So if you go to Postman and make a request, we can see that it's waiting. It's the hello to London, Seattle, and if I make a request to this, oh, I take too long. Let's do it again. We see that is running. If I use this status query, we can see that it's running. It doesn't have an output yet, And you can tell by the status that it's not done. And now going back to the code, we see that we were the tasks were added in this order: Tokyo, Seattle, London, Monterrey, Ciudad de Mexico, and London again, apparently. Well, you can see in real time that the first one to be finished was Mexico City, uh, then Seattle, then Tokyo. So you notice that it's not the order. You have all the tasks running in parallel. We mocked the time span it's going to take to finish them with this delay. But you can imagine in a real environment, you have many functions running in parallel, and each function might take longer depending on the input data or wherever, and they are all running in parallel. Maybe something to mention. We have here the Azure storage. This is the local emulation. We have these tables, which are called task hub. In every task hub, you have all the story of the activity. You can see an orchestration starter. A task was scheduled. A task was completed, and you can keep track of all this. Most of the time, you won't have need to take a look at this or worry about it. The system uses the in the backend. You don't need to worry about it most of the time. But if you maybe have a particular case, you need to debug something, you can take a look at this. This partition key, if I'm not mistaken, is the I'm sorry, this is the execution ID. If you remember back in Postman, you can see the ID of the execution, and maybe look up for it here in the hub. In the instances, basically is you can see what the status returns. You can see the runtime status completed. You have the output here, the name of the function, the time the timestamp where it was run. So yeah, so just so you can keep in mind that the Azure storage is needed, and this is why, because it needs these two tables to work properly. So it was a a brief demonstration. We didn't go very in depth, but just to give you a feel of how you can implement this technology. Moving on, there are some things to keep in mind if you were to implement this technology. First, there are some code constraints for the orchestrator. There are some others, but this one stood out for me, and I think it's worth mentioning. Since the orchestration is a stateful workflow, you need to always use deterministic code. So deterministic code is something that no matter when or how many times you run it, given the input, you're gonna have a predictable output. So if you were to use maybe dates and times, if you use the old-fashioned way of the integrated C# libraries, functions, datetime now, and so on and so forth, well, that's gonna pull the datetime of the VM, or the virtual machine that is taking care of that orchestration or that activity. So every time you run it, the Azure service gonna look for the next available uh, agent, which in this case might be a VM. And most of the time it's not a problem, but depending of the configuration of your service, maybe you can have a virtual machine in the central time, and the next run is gonna be the West Coast, and who knows. So this is gonna make introduce some errors, and so you would need to avoid that. But this is taken care of for the orchestration context. The orchestrator context have some daytimes methods that you can use, which are prepared for the durable context. So basically, it takes the data in a safe way, let's say. The same things go for UIDs and UIDs. If you try to get a new UID in the orchestration, basically it's gonna generate it on the fly, and you can be sure that the next time it runs, it's gonna be a different ID. Just like the datetimes, the orchestration context have some methods for this particular case. So it persists the IDs, so you can use them concurrently or in different iterations or runs of the orchestration. Now with random numbers, the random numbers, well, they're not very commonly used, but it can add some undeterministic issues. If you were to run a random function with a given seed data, and you know the seed data, it comes from the input, or is a known value, a constant or something, maybe you can get away with just random methods. But generally, if it's going to be unpredictable, you need to avoid them to keep the stateful nature of this implementation. There are some things you have to keep in mind when you make breaking changes, maybe a refactor in any of the functions, or the signature, maybe you change a type or some parameter, or you add a parameter, or maybe inside the orchestration you change how it's gonna process the data. Well, if you do some of those breaking changes, you cannot simply publish them to the cloud, because if there are some orchestrations that are not finished, that have some activities in queue, once the orchestration resumes, it's going to try to use the let's say compile. It's going to try to use a code that is not already there. So, or it's not the expected type, or etc., etc. So, well, sooner or later, when you deploy an application like this, maybe you have a bug fix, or maybe you have to add some functionality. Sooner or later, you're going to need to do this. So there are some mitigation strategies. One of them is do nothing, which is not recommended. But if you know your application, maybe you have an application of something of Internet of Things. Maybe you have application that starts your coffee maker in the morning or something like that. You can get it. You don't really care if someday it's not running. Well, you can simply deploy your changes. If there's an orchestration already running, maybe it's gonna fail, and you don't really care if that's the case. Sometimes in some business logic, you cannot allow an orchestration to fail. Maybe you need to see them through. So it's not optional in all the cases. Another option is to manually stop all the in-flight instances. So I showed you before in the storage, there are there's a history of all the activities that are run. Maybe you can go manually and delete the ones that you don't care for them to complete, or maybe even you can delete the whole tables. You can wipe the tables, and when you redeploy your Azure Function application, it's gonna restore those tables from scratch. So it's going to be empty. So there's not going to be any orchestration running or pending. So that's one way to go about it. If you can get away with deleting, stopping all the work, that's another option. The third option is side-by-side deployment, which I think is the most viable in most cases. So let's say you have a function called send to report. It's going to take some values and it's going to wait for some event to continue. Now you need to make a modification, add some data for future reports, and you go ahead and modify that function. Well, that's not going to work even if an orchestration is already running. So one thing you can do is maybe make basically a copy of that orchestration and call it send report B2, sort of like a versioning name scheme, and then the application that consumes this orchestration can be updated to now send the information for the report to the send report B2. So no longer there won't be any new calls to the send report B1, let's say. So it's going to take its course, it's going to complete its life cycle. You can deploy the new send report B2 and have both functions, both orchestration available in parallel. So the send report B2 can take care of all the new requests, and the send report B1 can finish up all the remaining work if it's any. And after some time, you're gonna have all the send report B1 finished, and you can at that point delete that function, or maybe revert back the name, or well, there's probably the most I don't know, complete mitigation strategy, in my opinion. So there's something to keep in mind. But if your application is not going to have many modifications, there's not something you can worry about. And now talking about pricing, but durable functions are, like I said before, basically and just another Azure function application. So it's going to be built the same way, which is by time use. For this very reason, is auto scalable in some way, because you're going to be charged just by the time it takes for all the functions to be run. In fact, I think there's a free tier, which is something ridiculous, like 1,000 hours or something like that. I don't remember, but you can make very complete applications with the free tier. And if your application suddenly gets a lot of users or something, it can automatically scale up. Once you exceed the free tier time, you're going to be charged just by the second that you use. At that point, maybe you are already making money for the application, so it's not really a concern. And like I said before, you need Azure storage, just like the functions. You have a free tier, which I believe is 500 megabytes, or maybe a gigabyte, I don't know. But there's a lot of free storage, and if you are not using entity durable entities, you're not saving data in entities in the storage. If you are only using the Azure storage to keep the ledger of the orchestration, you are going to use negligible amounts of data. I don't know, 100 kilobytes in a heavy use application. So for many applications, you can pretty much have this running for free. Maybe you have a startup, a project that you want to get up and running. This is an excellent alternative, because you're gonna pay pretty much nothing to have it lift off the ground, and once is catching on, it automatically scales with the users. And well, as a brief recap, we took an overview of the Azure Dual Function, how it works, some useful application patterns, a quick light demo, and some of the limitation and things to keep in mind if you want to use this technology. And if you want to know more about this technology, there's a very extent documentation by Microsoft. It's a quick Google search away, but here's the link and a QR code if you want to take a look at it. There's also the community is very active in the common places like Stack Overflow and all these forums. There's a lot of people in the community helping each other out. So this wrap up this talk for today. So thank you very much, everyone, for joining. I don't know if there are some questions that we can. If anyone has any question, we can take some time to see. I'll do my best to respond. Anyone? Well, so I think that's it. Thank you, everyone, for joining. And have a great day today.
Thank you so much.
You.
Thank you, Angel.
Thank you.
Thank you.
Thank you. You.